Welcome to the presentation of Where Should I Look? Comparing reference frames for spatial tactile cues. My name is Erik Pescara and my co-authors are Anton Stubenbord, Tobias Röddiger, Likun Fang and Beigl. When designing tactile displays on the wrist for spatial cues, it is important to keep the natural movement of the body in mind. Depending on the movement of the wrist, different reference frames can influence the output of the tactile display. In this paper, we compared an allocentric reference frame with a wrist-centered reference frame in terms of accuracy, reaction time, and cognitive load. We conducted a repeated measures user study with 20 participants. We used a tactile wristband with 10 evenly spaced actuators as our tactile display. The data we retrieved from the experiment consisted of 120 spatial localization tasks per participant per reference frame. As a measure of cognitive load, we asked the participants to fill out a raw TLX survey after every condition. A spatial localization task was conducted as follows. First, a combination of wrist rotation and actuator was drawn from a predetermined list. The participant was then instructed to turn the wrist to match the given wrist rotation. Depending on the reference frame, the corresponding spatial direction was calculated. The selected actuator was then activated for 1 second. The participant then was asked to input the direction. The input was stored together with the reaction time and the true direction. This process was then repeated until the list of spatial localization tasks was exhausted. In the evaluation, we first looked if localization accuracy was influenced by the reference frame. Both reference frames had a high localization accuracy for the wrist and showed no statistical difference. While the wrist-centered reference frame had an accuracy of 84% and an average error of 28.5 degrees, the allocentric reference frame was only marginally better with an accuracy of 85% and an average error of 26.8 degrees. When comparing reaction time, we can see a difference between the reference frames. There is a statistically significant difference in reaction time with a small effect size. The allocentric reference frame has a slightly faster reaction time with an average difference of 240 milliseconds. For measuring the effects of the wrist rotation on the participant's reaction time, we performed a linear regression analysis with the wrist rotation as predictor on the reaction time. While there is a clear relation between increasing reaction time and higher wrist rotation for the wrist-centered reference frame, the allocentric reference frame is mostly unaffected by the wrist rotation. For measuring the effects of the wrist rotation on the participant's accuracy, we also performed a linear regression analysis with the wrist rotation as predictor of the accuracy. While there is a clear relation between decreasing accuracy and higher wrist rotation for the wrist-centered reference frame, the allocentric reference frame is mostly unaffected by the wrist rotation. We looked at the data collected by the raw TLX questionnaires to analyze how the participants' mental demand was affected under both conditions. The raw TLX data was separately evaluated for each dimension. The allocentric reference frame yielded better results in every dimension. There was a statistically significant difference between the reference frames in all dimensions, with most dimensions only having a low effect size. However, we found that the mental demand dimension had a large effect size and the performance and effort dimensions had a moderate effect size. Participants also described the wrist-centered reference frame as far less intuitive and more demanding. This leads us to conclude that the mental demand of the allocentric reference frame is lower than the wrist-centered reference frame. Linear regression was used to measure the learning effect during the experiment for both conditions using trial number as predictor for reaction time. No statistically significant evidence was found that the trial number influenced the reaction time for the wrist-centered reference frame. We found statistically significant evidence that the trial number influenced the reaction time for the allocentric condition. Our participants improved their reaction time in the allocentric reference frame during the experiment. In conclusion, in the experiment we conducted, we found evidence that an allocentric reference frame outperforms a wrist-centered reference frame for spatial localization tasks with a wrist-worn tactile wearable. In our experiment, the participants had faster reaction times with the allocentric reference frame and improved during the experiment. We found evidence that the allocentric reference frame was mentally less demanding and more intuitive. And the allocentric reference frame was more robust against posture changes compared to the wrist-centered reference frame. In the future, we would like to investigate the influence of different reference frames for spatial localization tasks in the wild with a broad range of activities. We would also like to include more than just wrist rotations in the posture changes, and, as there is conflicting evidence in the literature which reference frames perform better in which circumstances, we would like to investigate this further. Thank you for your attention and have a great day.